Don't worry. I thought the same thing as well, for the longest time. Right now, as a first-year chemistry major, I wonder perhaps more than I should about why I should give a damn about physics. After all, since I'm a chemistry major, shouldn't I be focused on, chemistry? You know, how molecules work, how the atom is structured, the electron shells, or even why the hell I should care about relating vapor pressure and enthalpy together in this monster of an equation. Students all around the world struggle with this, wanting to study something that they truly love, but being bogged down by these classes they couldn't care less about. If you want to be a game developer, a history major, or even a linguistics major like I once was, why should you care about physics? Hell, why should you even give a damn about math in the first place? There's all these convoluted and seemingly arbitrary formulas and equations, and all for what? Today, I'm not hoping to turn you into a math major. I'm not even hoping to help you turn your hatred of math into a passion. What I do hope to achieve, though, is to open up your mind and to explain simply why math matters. And perhaps more to myself than to any of you, why the hell you should care about physics. I'm going to keep this short. Physics is the study of how our universe works. Simply put, it is the foundation that underlies all other science, with the only level below it being mathematics itself. Want to know how fast a sound wave travels through the air and resonates in your ears? Physics. Want to know how dense a section of the ocean is? Physics. What about the atom? After all, didn't I just say that I'm a chemistry major, so shouldn't I be studying atoms instead of some physicist? And what about those quarks? Elementary particles? That seems more akin to something a chemist would do, wouldn't you say? No. Well, in a sense, yes, that is true. It's true that chemists do study atoms, but only up to a certain point. How will two hydrogen atoms react in the presence of a hungry oxygen atom hunting for electrons? That's chemistry. What are the forces behind such an interaction? As in, how much force is generated between the atoms and the electrons, and the specific energy threshold needed to steal those electrons away? That's physics. What about the force between two separate molecules bumping into each other? What force will be generated, and what change in motion will occur? How would temperature affect this? On the surface, it seems that chemistry could answer all of these questions, and to a certain extent, that's true. But only to that certain extent. Physics will give you more specificity, more nuance, more knowledge and depth than any other chemist could hope to achieve. Physics holds the answers to our universe, holds the mechanisms of how it works, and the rules and laws for making sense of it. As much as we feeble humans could anyways. Together with physics, as well as loads of calculus and differential equations, as well as some other spicy mathematics, our universe turns from an indiscernible mesh of stimuli into a series of equations, predictions into the future, and why the past happened as it did. So maybe history and linguistics and even English majors can study the cultures arising from sentient beings inhabiting this universe that we call ours. But if your goal is to understand how that universe works, its mechanisms, its rules, what governs it, well, look nowhere else but to physics. Only physics can tell you how fast an atom will move, or the force between two hydrogen atoms colliding together. Maybe that seems really boring, but you've also got to think about the fact that, well, because of physics and theories and special relativity and general relativity derived from many, many famous scientists, including but not limited to Albert Einstein, we can describe phenomena that we haven't even seen before, such as black holes. Physics is so powerful that it can even go back in time and trace back to our universe with overwhelming evidence to an event called the Big Bang. Although this theory has been a combined effort between many, many different fields of science, the predominant one is physics and the subdivisions of physics. So, even while I sit here, record this video, dreading my homework on kinematics and figuring out how fast the ball will go if I kick it at a certain angle with a certain speed, I have to remind myself that, well, my ultimate goal in this learning adventure is not only to have a degree in chemistry and later in forensic science, it's also to discern as much as I possibly can about the universe that we live in. If that's your goal too, like I said before, physics would definitely be up your alley. Maybe you don't have to be a physics major. Maybe you don't have to be in astrophysics, working at NASA, looking at stars and deriving formulas for how all these different new phenomena in our universe and space work. But you can gain some knowledge. Maybe from Newtonian physics to discover how the very big work, all the way down to eventually special relativity, general relativity, quantum mechanics, particle physics, etc., to learn how the very, very small work. At the end of the day, though, no matter what you choose to study, even if it's the farthest thing away from math, physics will most certainly play a role in your understanding of a topic and the universe around you. Thank you for listening.